All right, so we are reviewing for summative number 4 in the fall of 2019 in PreCalc. This is a very long review, so in order to get through as much as possible, second hour is going to offer me lots of answers as I ask them very quickly. And then there's a section coming up where we have to use the calculator. I'm going to trust that y'all know how to use your calculator to find your maxes and mins and zeros. So first, before we get going, here's your next warning for expiration. Next Friday, we're going to expire the quadratic standards. Okay, so that goes all the way through quadratic applications, which are those questions where, like, how many hot dog vendors should you have to maximize your revenue? So that was on the last test. So everything from quadratics, you cannot retake after next Friday. Next Friday. So you have 3 days this week, and then all next week. Okay? Sure. Positive way to think of it. All right. So don't dawdle on those. That would be our advice to you. Why is nothing working? Okay. So first question, get your bifocals out and evaluate a function for me. Do we need to do this one? Yes? Okay. So when it says f of 4, is this an x value or a y value when it's inside of the function like this? That's an x value. So you need to go to your graph, which thank you, Hofbauer, you made it bigger for me. And then find what happens when x equals 4. So take a look. 1, 2, 3, 4, and then go find your graph. So what output are you getting there?
Negative.
Yeah, me neither. So first hour thought it was -6. I think when I keyed it, I probably thought it was -7, but I can't read this. We all know that. So,
Oh my gosh.
who knows? All right, -1. Again, this is an x value. So go over to where x equals -1, which is right here, and find your graph. That one's a little easier for me to interpret. I'm thinking that pops out at -1 as well. So coincidental that the x and y values matched on that one. And then there's an extra question here where it says f of 0. Again, this is an x value. So you go to where x equals 0, and then boom, there you are. What output is that?
0.
Yeah, it's 0. Okay, average rate of change. You had a bunch of homework questions where they wrote them as an interval. So you may have seen it like written like this, where an interval from 2 to 4. That just meant your two x values were 2 and 4. So what I need from you guys is you got to find the ordered pairs at x equals 2 and x equals 4 in any order. Plug them into the function. And get your y values. So real quick, guys, if I plug in a 2... that is 2 squared, or -11. And if I plug in a 4, that is -47. Will we double check that? It's a Monday morning math problem. Okay. So now this is where some of you had a little moment of you forgot what this meant, and I had to do a lot of writing on tests. Average rate of change. Give me another way of interpreting that. It's just slope. So y2 minus y1 over x2 minus x1. Just watch your order. -36. Is that -18? I think. So there's an extra question up here. We can do it if you guys need it. For the sake of time, I'd love to move on. There's a whole bunch of homework questions that are average rate of change questions. There's some in that Piecewise packet. There's a couple on the 1.4 bookwork. So please double check that you've accomplished those. And guys, I'll also be checking for your work on those questions. I don't want to see answers with no work anymore on average rate of change questions. All right, last test, I had a few people interpret this question and say, well, yeah, it's a function because it passes the vertical line test. Which is true, but what's the problem? Yeah, you haven't shown me the vertical line test. So in order to claim it's a function because it passes the vertical line test, you'd have to graph it, or at least give me a sketch. So this is an absolute value that was shifted up 3, so it looks like this, kind of. Except it actually looks right. And then, if you really want to impress me, you'll even go through and humor me with some vertical lines that show it passes the vertical line test. So I'm okay with this reasoning, guys, but you literally have to show me the vertical line test to use it as your reasoning. Yes, Daniel? Yes, just be careful. Because, like, sometimes you think that's true and it's not. Yes, it should be true. But I just don't, like, it's a 50-50 shot, and sometimes kids shoot wrong because they don't know either way. They're just hoping for the best, you know. Just be careful. Be flexible. Be able to come up with both if you have to. All right, guys, write a list of ordered pairs that is not a function. I'm going to start off this list. And I want you to give me one more ordered pair that would create a situation where I don't have a function in this case. I mean, you got a lot of options. Just give me one that works, or in this case, doesn't work. Okay, why is this not a function? Because x equals 3 has two different outputs, and therefore it is not a function. Very good. Okay. This question, you guys did really beautifully on the last test where you evaluated a function with a binomial expansion. This is a little more tricky though, because there's a coefficient. So because you have to take a minus 4 and square it, and you also have a coefficient of -3, you guys have to do this in 2 stages. And sometimes kids try to be crafty and do it all at once. It usually 100% of the time backfires, I'm gonna be honest. So don't do these at the same time. I don't mind if you expand this pretty quickly. A minus 4 squared, you guys did a great job of doing a minus 4 times a minus 4, and that ends up being a squared minus 8a plus 16. But don't forget, now you do have a coefficient of -3 in front of that, plus 1. So now would be a great time to distribute the -3. So -3a squared plus 24a minus 48. Don't forget there's a plus 1 off to the side. So finally just combine those two constants at the end, and you'll have your final answer. And that's a great question for a pre-calc kid. Making sure you're careful on your algebra, which is what Mrs. Gupta always complains about in calc, is that the kids are sloppy algebra doers sometimes, so don't do that. This question, though, is really closer to what you're going to see on your test. And at first glance, kids look at this and go, oh, well, that's even easier. Your math teacher would disagree, just because of the things that kids like to do to this question. The first issue I'm going to have is a bunch of kids think they're supposed to multiply the -3 times the -6, and then voila, they get an 18. Is that how math works? No, because order of operations states you have to do parentheses, then exponents, then multiplication. So you are not ready to do any multiplication yet. So then the kids who decide on the parentheses first and the exponents, I still get some wrong answers from kids because they are calculator happy and they type -6 squared without using parentheses, and they tell me this is -36n squared. Is that right? No, it's positive 36n squared. So remember, your brain works great too. You guys are real good at mental mathing, so if you type something, just do a quick double check, like, yeah, that was right. Now you can take care of the multiplication. -3 times the coefficient of 36 is a -108n squared, and then there's a plus 1 off to the side. So the one on your test is closely related to this, which I know seems easier, but for some reason it's not. Tricky pre-calc. All right. So we're still in old stuff. Domain and range. The most common issue I saw from you guys on domain and range is that you got a little confused with the interval notation. It has to go least to greatest. So for domain, that means left to right, and for range, that means low to high or bottom to top. So domain, where does this domain begin? Okay, with a bracket or a parenthesis. Very nice. Bracket because of the point. And then how far out to the right will it go? Now notice how they said infinity, not negative infinity. A lot of kids get confused because it's pointing down, but remember domain is reading to the right. That's a positive infinity that you're heading towards. Your range starts how low? Good. Starts at negative infinity, and then as you travel up, where does it stop? I think it's 4. 4 with a bracket? I don't know. It'll be a little easier to read on the test, so hopefully. Otherwise, I guess I'll be very gracious with what I accept for answers, since I too can't read. There's that dot paper. All right, so make sure you are working on your intervals, always going from least to greatest. In pre-calc, the minute you mess up domain and range, it's a concept error. So like, if you meant to put a bracket and you put a parenthesis because you're a little confused, that is a 3. Okay? If your interval is backwards, that is a 3. If you just can't read, it's probably not a 3. I'll have a little empathy for you, I guess. All right, discontinuous. How can I tell quickly where this rational function is discontinuous at? Where do I investigate? Where, though? All of them? Just the denominator. The issue is the denominator cannot come out to a 0 because that would be dividing by 0, and everyone knows that's a problem. So you got to solve this somehow. Easiest way to solve these would be factoring. This factors into x minus 6 times x minus 1. So tell me, what are the two values where we are discontinuous? At x equals 6 and x equals 1. Very good. I don't care what's going on in the numerator. That has nothing to do with our continuity in this chapter. Okay? Just the denominator. All right. All right. Can we have a moment when we talk about symmetry and even oddness because this was sad. Let's talk about odd. Do you guys remember the algebraic testing for odd? So if you're algebraically testing it, you can plug in a negative x into your function. And then what happens? What do you get out of this process?
I don't remember.
I know, and I remember you didn't remember on the test either, so let this be a moment. You get the opposite function out, okay? So what that looks like is this. Basically, it's your original function with the opposite signs thrown in front of every term. So if your function was 2x minus 3, it would end up being negative 2x plus 3 when you're done. That wouldn't be odd, though, by the way. That was a stupid example. It wouldn't happen. Like, I gave an example of a line. That line isn't odd. The algebra worked, but it didn't make any sense. Just ignore me. I should have came up with something better. Okay. What kind of symmetry does an odd function have?
X-axis.
No.
Y-axis.
Origin. Okay. Odd, opposite, origin. Ooh. All right. Now, what does it look like when you're investigating and you're looking for origin symmetry? Well, this is the way I explained it in the first hour, and I think it made more sense to some kids. Whatever's going on in quadrant 1 is going to match what's going on in quadrant 3. Okay? These are going to be carbon copies of each other. And then whatever's going on in quadrant 2 is going to match what's going on in quadrant 4. That's what you're looking for. Symmetry across the origin like that. Does that make more sense? Yeah. Okay. So let's talk about the other type of function symmetry that we might have, which would be even. So the algebra test, it starts off the same way. You plug in a negative x into your function. And do you remember what you get out of it? Yes, you get the same function back again. Meaning I don't want to say original because that's another O word and that's really confusing. So I'm just going to say the same function like Taylor did. Same function back again. So talk about symmetry. Even functions are symmetrical how?
X or Y?
It's one of them. Which one is it? And if you forget, think about your world's favorite symmetrical even function, the normal mama parabola. Mama parabola looks like this. So you tell me what she's symmetrical with.
Y.
The y-axis. Yes, very good. So if I go back a slide, we have some examples that are drawn for you, and you have to determine symmetry based on their visual symmetry. So tell me if even, odd, or neither. Whew, this one, a relative of the mama parabola, but I don't think this is mama. See, it's shifted over, therefore no longer symmetrical about the y-axis. Ooh. So tell me, even, odd, or neither? Neither. That's a neither. Yeah. If you translate right or left, it is no longer going to be even. You want the algebraic reasoning why that, or you?
Yeah,
okay. So if you have a function that's translated to the right 2 units or whatever. Okay. If I were to plug in a negative x right here. And you simplified it. I got it into standard form. Okay, this guy would be x squared minus 4x plus 4. This guy would be x squared plus, no, hold on. Yes, plus 4x plus 4. And if you compare these two functions, They're not the same, so it evens out. And they're not complete opposites where everything has the opposite sign from the original. So this is a case of algebraic neitherness. The visual symmetry of it is it doesn't have any. Can we talk about this one, though? It's odd, yes. So notice what's going on here in quadrant uno looks the same as what's going on in quadrant tres. And then here and here we got some symmetry. So that's what you're looking for odd. Is anything down here even?
Yes.
Who? Thank you. What do you think about this one? Because a lot of kids look at that and they tell me it's even. Because they're like, what do you mean? It's right in the middle. And I'm like, no, this guy doesn't even have the same height as that piece. That's very wonky. Okay, so that one is a neither. Just FYI, that's a neither. I would agree that this one's neither. Let's talk about that first one real quick. Yeah. I don't know why I was questioning you, but yeah. I don't know. Honest to God, my eyes didn't move that far over yet. That's where I'm at today. I need more coffee. Okay, symmetry. Get it right. Okay, this question. This is the one where I'm assuming that you guys can find your x-intercepts, your maxes and mins on your calculator on your own. Okay, is that an okay assumption? If it's not an okay assumption, then that just maybe means you got to come in and talk to me before and after school and practice that part with me, okay? That's not even the right graph. My bad. The graph does not look like that. Let me give you some facts about this. First of all, we're going to ask you to graph it on your calculator and come up with a good window on your own. This particular question, you would have to play with the window a little bit because it goes a little higher and lower than the standard window, so you'd have to adjust your Y max and min. There are two zeros that you would find, and I'll just tell you what they are. Negative 0.5, 0, and 2.1, 0. So let's pretend it's here and here. And then I will ask you to find your turning points. So there's a minimum and there's a maximum on your graph, which you would find on your calculator, but I'll just go ahead and give them to you. The minimum is at negative 3.6, negative 35.2. That's why the window had to extend down. And then the maximum is at 0.9, 11. So the window had to extend up as well. So if you pretend like you know where those numbers are, which I totally don't. Okay. So your graph ends up looking something like this when you graph it. Oh, God. Oh, no. Okay. Just got worse. Something like that. You guys would do a much better job when you had actual good information to work with and a coordinate plane. Now, I'm about to ask you about increasing and decreasing intervals. Before I start talking about intervals, what should I do? What's always worked for you guys? You've busted out the highlighter and done what?
Highlight.
What are you going to highlight, though?
X value.
Of whom?
Of everything.
Not everything.
Zeros.
I don't care about the zeros.
Oh, no.
Yeah, the turning points are the places where your function changes roller coaster mode from increasing to decreasing. So if you were writing these on your graph, which I always suggest, I think this is a brilliant idea when you guys label it on the graph as well, I would highlight them here as well, because it gives you a really nice visual representation of what's going on. I think that's even smarter, because then you won't be tempted to use the wrong one. So Taylor said, what if I just write down the x values? And I was like, brilliant. You won't be tempted to do the wrong math? Okay, let's talk about roller coasters. I definitely see a piece of this roller coaster that is increasing, and it goes from here to here. So my question to you is, when is your roller coaster increasing?
0.36. Oh, yeah.
Yep.
2. Positive. 0.9.
Very good. Parentheses on both ends of the interval, because we're always using parentheses on these interval questions for increasing and decreasing.
Yeah.
We are. So then decreasing. There's two pieces where it's decreasing. Yonder and yonder again. So when is it decreasing? Starting in proper interval notation, please. Negative infinity, and then it keeps decreasing until when?
Negative 3.6.
Very nice. And then it also decreases from
0.9.
0.9 until, Very nice. Notice Cameron's use of positive infinity there. A lot of kids are tempted to use a negative infinity because it's heading downwards, but that has nothing to do with domain. All right, so here, it's a little confusing because there's a lot going on my graph already. I'm going to ask you next for an inflection point. So the inflection point literally can be estimated, but it's best if you guys calculate an inflection point for me. It is midway, so midpoint, between your maximum and your minimum. So those two things that you highlighted for me, could you find the midpoint between them? I think it's like negative 1.34. Can I get a confirmation on that? So it's like roughly right here. Now to find the other part of the ordered pair, which, guys, I'm going to be honest, I don't even care about. But you're going to have your function on your calculator when you do this question. So it's as simple as just going to your calculator and then saying trace, just pull up the cursor and type negative 1.34 and then enter. So negative 12.2. Sounds good. Okay. So it's not hard to evaluate a function when you're already looking at the graph and it's already in your y equals screen. I forgot what it said. Negative 12.2, I think. All right. So now this is where it gets a little complicated because now I have to talk about concavity. And I don't know about you guys. I'm having a hard time looking at that graph right now. So what I'm going to do is I'm going to do this. Give myself a really horrible sketch of it, apparently. And the only thing I'm going to mark, I'm going to take a page out of Taylor's book. I'm just going to mark down the x value that we were working with. Because remember, we're only using x values for domain intervals. So we're only using this guy. So let's talk about frowny face, happy face. This piece of the roller coaster is referred to as concave up. It is a smiley face. The next piece of the roller coaster after the inflection point is concave down. So when I go to write the interval for concave up and down, this time you're only allowed to use the number negative 1.3 or negative 1.34 for any beginning and ending of an interval. So let's start with concave up. When is it concave up? Reverse that for me. But yes, negative infinity to negative 1.34. And then when is it concave down? Negative 1.34 to forever. Very good. It's always read left to right, yes. Yep. Everything on this question should be read left to right. I know, it's confusing. Then they just throw stuff at you. All right. I'll post the slides, and if you feel like you need to practice some more, you go right ahead. Transformations. All right, newish stuff, but a lot of it's not newish. And every time I called on a kid earlier in this lesson, earlier today and last week, they all started panicking and reaching for their packet. Okay, because they were really nervous they weren't going to call it the right thing. So I need you guys to use a little bit of trust in your old math skills for me. When you throw a 3 in front of a function, what does that do? What is it called? I know, you're all like, ah! It's a vertical stretch of 3. Very good. I know you knew that, but the look of panic in your eye. All right, look, a vertical stretch of 3. Now, I'm just going to, because there's no distribution, I'm just going to read this from left to right, and then I know I'm in the right order. When I put a plus 5 inside of the body of the function by the x, how does that move things? Okay, so it's a left 5. Very good. And then when there's a subtract 1 off to the side of the function, that's going to shift everything down 1. Outside of the function will be a vertical shift of, in this case, down 1. It didn't make a big deal about order on that question, so this is more like an Algebra 2 question that we just saw. Don't worry about distributing into something that's cubed. That doesn't really help you any. When I throw a negative in front, though. Oh, there we go. I'm looking for a reflection. You can either say over the x-axis, or you can say a vertical reflection. I will accept either of those. If you just write down reflection, that's not good enough. And if you write flip, you make me cry. I'm going to take your test and flip it out in the garbage. What? and a reflection across the x-axis. Very good. It would have both. Right. That means weirdness. Good girl. She says those are two different transformations.
That means your line implodes and the universe ends.
It's just like dividing by 0. Don't do it. All right. When you have this 2 inside of the body of the function like this, what does that mean to you? It's by the x, so it's horizontally doing something. What's it doing?
It's moving to the right too.
Yes. And then a +7, not with the x, so it's a vertical movement. Up 7. Cool beans. All right, this is where order is super important, guys, and this is where I think I'm going to get some of ya. So the function, the parent function that we're going to be moving is the square root of x. So I'm going to write him down, or her down, whoever. Let's start applying these transformations in this exact order. So the first transformation they want me to do is a vertical, they're calling it a shrink or a compression of 1/2. What does that look like? Where does it go? Is that vertical? No. Inside's all horizontal. So it's the a value. Yeah, it's the normal one. So instead of like the last question had a 3 in front because it was a vertical stretch, this is a vertical shrink or compression. So we're going to just, are you okay with this?
Yes.
Okay. Now we got to go on the inside because it's horizontal. I could do that. Yes. Yes, let's hypothesize. If it said horizontal shrink of 1/2, what would that have looked like? That would have been a 2 on the inside. Very good, very good. That would be nasty and mean. I'm going to do that. Okay. What does left 3 look like? Where? Inside. Horizontal stuff inside. Okay, up 5. What does that look like? Outside. And then just for funsies, we don't usually do this. At the end of my problem, I want you to reflect it. So just do this. Thank you, Adam. If you want to apply that reflection at the end of the problem after everything else occurred, you got to do that. So with that in mind, what else would I accept as a correct answer? Nope, just distribute. This is one term. But this part, yeah, then it turns into a -5. So I know your next question is, well, which one do you want? And my math teacher answer is either. I don't care. My lazy person answer is the one that requires less work and less chance of having a mistake. So that would be this one. Okay. So watch out. That order matters. Okay. So we had a worksheet a while back where we had to match 1,000 graphs to each other. And what we did is we picked like our favorite point and we started moving that favorite point around. Well, this is a little more complicated because not only do you have to like think about transformations, you actually have to create the new graph. So with that in mind, I suggest you take these, what look like vertices on this weird looking graph and label them. So break out the bifocals. I think this is 3, 0. I think that's 2, 3. I think that's 0, 3. And I think that's -3, 0. So what we have to concentrate on now for this question is when you guys identify the transformation to me, you have to talk to me about who's going to change. Is the x going to change or is the y going to change? So this first one, let's get him graphed down right here. When I throw a 2 in front of the function like this, what does that mean to you? Yes, a vertical stretch of 2. So that's going to take all of your y values and it's going to multiply them all by 2. So this ordered pair of 3, 0, well, if you multiplied the 0 by 2, it's still going to be at 0, so that's kind of lame. But this guy, if you multiplied the y value by a 2, you're going to be at 2, 6 now. I can't count. 1, 2, 3, 4, 5, 6. And then this guy, if you multiply that y value by a 2, he's up here at 0, 6. And then -3, 0 doesn't get stretched because it's on the 0, so. What does f of x mean to you? What is f of x a fancy way of saying? So this is literally 2 times y. Okay? And it's a vertical stretch, so it vertically stretches all your points. Yeah. And now we're supposed to play connect the dots, which, oh man. Yep. Okay. That's looking a little like a Greek letter, but that's cool. Okay. So anyways, let's talk about this one. There are two transformations there. Can you identify them for me? Reflection over the x-axis, so that means a vertical reflection. I know it says x-axis, but that does mean vertical. So that changes your y values, right? It negates your y values. And what about the +3 inside by the x? What does that do? That moves everything to the left. Now that changes all your x values. So good news. Nothing, yeah, order doesn't matter. X and y won't affect each other. So you take all your ordered pairs, and in any order you want, you can move them left 3 and reflect them across the x-axis. Yes, Daniel?
How do you tell when you can do it in any order?
When order matters? Identify whether you have two vertical things or two horizontal things. In that case, it matters. So if we also had like a +2, and there was no parentheses around the whole thing, you had to do the reflection before you do the +2. Okay, good question.
Right.
It would be a -2, yeah. So what a lot of kids do is they just distribute anything, and then they just read it left to right. That's the way I do it, because, you know, I got problems. I got a sign outside that says it. All right, so if I took this ordered pair and I shifted everything to the left 3, I'd be at 0, 0. Guys, when you reflect 0, 0, you're still going to be at 0, 0. Now, this ordered pair, if you move him to the left 3, you're going to be over here at -1, 3. And then if you reflect it across the x-axis, you're going to be at -1, -3. I can't see that right here. 0, 3, if you shift everything to the left, you're going to be at -3, 3. 1, 2, 3. And then again, reflecting it down here. I don't think I counted right. Is it okay? Okay, I'm good. And then this last one, -3, 0. If I shift it to the left 3, now it's at -6, and then reflecting a 0 doesn't do anything. I don't know if that's counted right. 1, 2, 3, 4, 5. Yay! All right. So there we are. Kind of. Can we talk about that last one, though, in the group? That's the one I'm worried about. What is that? What direction? Start there. It's inside with the x, so it's horizontal. Why is it a compression?
Horizontal compression.
Everything's backwards.
Everything's weird. So it's inside of your function. You got to think backwards opposites do something that's not normal, apparently. So it's actually a horizontal compression, and I always say of 1/3, because what that tells me to do, it takes all of your x values and it thirds them, multiplies them by a 1/3, or divides them by 3. So 3, 0 is all of a sudden going to be at, I'm going to do over here, at 1, 0. And then 2, 3, if I thirded this, I'd be at 2/3, 3. Gross. I'm not going to be able to draw that. And then 0, 3 is still going to be at 0, 3. Oh my gosh, like I'm going to be, come on. All right, and then -3, 0 is going to be now at -1, 0. I know, right? How am I supposed to?
What the heck is that?
Right? That's what oh man. Okay, so step back, even in my ugly version of it, if you kind of step back and look, does it definitely feel like it was horizontally shrunk?
Yes.
Okay, definitely something happened horizontally. What I want you to notice, though, guys, it's not going any higher or lower than the original. The heights didn't change. Only your x is pulled in, okay? Yes. Okay. All right. You got lots of practice on that in your homework, so hopefully you've been keeping up. Yeah. It sounded confident. All right. This is what you did for homework for me last night. Identifying a parent function and then doing a little work so you can find the stretch. So what I always suggest you guys do on last night's or on the weekend's homework was you write the transformational formula for the parent function. Who remembers what this guy is?
Oh, it's a
square root function. So it's a times the square root of x minus h plus k. And then you go find your favorite point of the function, the beginning point in this case, the hk, which is at Okay, cool. So this is your h and this is your k. And then you need to use one of the obvious ordered pairs that they provided to you, which hopefully this is one of them. What is this?
Personally, I like -5, 2.
Okay. -5, -2? Okay, so there's a random xy ordered pair that we can use. Now, we were warned on Friday that sometimes the graph isn't as pleasant as it appears to be. If I can follow your work and your work is good, I will give you the benefit of the doubt that your function is probably right and mine's wrong. I think we labeled them for you on the test, so you shouldn't have to think too much. So now we're going to fill in our x, y, our h, and k. The only thing that we don't know is a. So y value of -2, I don't know a. The x value from that ordered pair was a -5, and then you're subtracting a -6, so you end up with this plus minus thing, so +6, and then plus k is a +1 on the outside. I always suggest you guys simplify by figuring this number out first. Oh, look, another 1. Okay, they're not always going to be 1. This is the square root of 1, which is 1. So you have -2 equals a times 1 plus 1. At least this one you get a little subtraction before you're done. Let's subtract this 1 from the other side to the other side. And careful, you get -3 equals a times 1, so a is -3. So to write the equation, you're going to go back and plug in that a you just found. You're going to plug in the h and the k that you already knew, and that's your function. So function is y equals -3 times the absolute value of x, and then we found out it turns into a square root. Yeah. Sorry. I mean, whatever. I hardly know your names. Why would I know the names of functions? It's rude. All right, +1 on the end. Like I said, square root. Oh, Lordy. All right, piecewise. We got to talk about it, and we have 5 minutes to do it. So, evaluating piecewise functions. You just got to be careful that you're in the right piece of the piecewise function. So, for instance, f of -5. Are you using the top, middle, or bottom? Uh-oh.
Wait a minute.
My dyslexia. This function is used if your x is less than -2. Is it -5 less than -2? So you'll be plugging into that top function. Let's see. That's a 1 squared 1. 1 times -2 is -2. Oops! Oh no, sorry, I got confused for a minute. My eyes moved and then I got confused. I'm telling you, I need coffee. Okay, so talk to me about x equals -2. This is where I got confused. I thought I used the wrong function because I looked over here. -2. A lot of kids tell me, oh, you should use the top function in Algebra 2, but you're going to school them and say, no, child, you use the middle function for -2 because that's the one with the equal to bar. It's 3. Very good. It's a constant function. It's very boring. And then let me guess, the last one you use the bottom function.
Yeah.
And that's what absolute value bars look like. Thank you. All right, graphing and discontinuity. All right, let's answer the discontinuity thing real fast. The only places discontinuities would occur in our piecewise functions for PreCalc would be at the boundary lines. So what you're going to do is you're going to identify the two boundary lines. So for us, that would be at -2. And then there's another boundary line at 3. And if you notice what I'm doing here, guys, I'm coming up with two ordered pairs. So on either side of the boundary lines, you have competing function pieces, right? So for -2, even though it doesn't actually exist, I still want you to plug -2 into this function, which I think we already did on the last screen, didn't we? No, yes, no, we didn't. Plug in a -2 for me. 2 squared 4 times -2, is that -8? And then this one we already knew. This came out to a 3. Do these meet up? They're going to be the same point? So that means you got a big old discontinuity right there at x equals -2. There's a jump. One side of the piece is at -8 with an open circle. The other one's up at 3. They won't connect. But look what happens for 3. So on the boundary line of 3, if you're on the left side of it and you plug into that function, y'all get a 3. But then look what happens when you plug into this function. you get, let's see, 2 times -3, so -6. -6 plus 9 is, oh, looky that, 3. So for both pieces of the piecewise function on the outside of that boundary line, they do match up. So this is continuous. So if I was to ask you, where is it discontinuous, you would have to explain that it's discontinuous at x equals -2. You don't really have to go into great detail as to why. But just because there's a boundary line, it doesn't mean we have discontinuities every time. Sometimes they do connect. I don't know if I have time to do both of these. So would you rather graph or would you rather create? Create. Okay. So there's one boundary line in this problem. And you're welcome. They're both going to be linear. Now this one, if you could please add an arrow over here, but don't add any arrows over here. Your function has 2 pieces. Let's talk about this first piece. I'm going to call it the blue line. When does it exist? Okay, it is constant at -4. Cool, so it looks like that. But what's the restriction? If x is...
if it's less than...
Good. I noticed you didn't say equal to. Why not? Got an open circle. Very good. Now this red, let's call this one the green one. I already used red. Still a line. So you're going to use your good old mx plus b formula. If you could find slope and intercept, you'll be good. -1, isn't it? So -1x. Where's the intercept? Is it -3? Okay, cool. And that exists for x's that are... Oops, it's sandwiched. My bad. You guys see that it's sandwiched? There's another boundary line right here. If x is between -1 with an equal to bar and 3. But notice 3 had an open circle.
Wait, would it be greater than negative?
It does say greater than. Remember, it's backwards. X greater than or equal to -1. Yeah, when it's sandwiched like that, you gotta write them that way. Awkward. Okay, so we will post the key shortly. Should have more examples, and there's extra examples in the slides themselves. So if you're like, man, I need to practice that more. Hey, you know where's a really good place to look for problems that you're supposed to practice? Your homework check. Some quality questions there, man. Okay, I'll be here after school today, and I will be here before school tomorrow. So come on in.